Hello, namaste everyone. Hope all of you are well. Today, I just want to give you some information about, first of all, atom. What is atom? All of you know very well. If I draw this structure and I put a nucleus here, then you can directly say, yes sir, this is the structure of atom. But you know, in the atom, proton and neutrons are present, and on the path of this orbit, electrons are present. This thing you know very well. Electron revolves around its own axis and on the path of this nucleus also. This path of this nucleus is called orbit. All of you know very well. And the maximum probability of finding an electron in an orbit is called orbital. The maximum probability of finding an electron in an orbit is called orbital. So what you have understand? In the nucleus, proton and neutrons are present. The path of this nucleus where the electron removes, that is called orbit, and the maximum probability of finding an electron in an orbit is called orbital. Right? There are 4 types of orbital. How many types? 4 types of orbital. I hope all of you know very well. S orbital, p orbital, d orbital, and f orbital. Right? How many types of orbital? 4 types of orbital. S, p, d, and f. So what you have seen? What is s orbital? What is p orbital? What is d orbital? And what is the f orbital? You can ask me. So as you have learned in the second chapter, structure of atom, that there are number of cells in an atom, energy levels, that's called energy cells, right? The first cell was denoted by K, second cell L, M, N by the Niels Bohr. Have you remembered the formula? The number of electrons present in an orbit, that is 2n squared. You have remembered, I think so. The number of electrons present in an orbit. How many electrons will be present in one orbit if the value of n is equal to 1, similarly second, similarly third. And I hope all these things you have learned in the second chapter. Now what I want to teach you, that if the electrons are present in s orbit, so which type of elements will be there? If the elements are present in p orbital, which type of elements will be there? If the elements are present in d orbitals, means the last electrons are present in these orbitals, so which type of elements will be there? So dear student, now the main topic I am coming. Our chapter name is S block elements. What is our chapter name? S block elements. Why I have taught you these all the things? Because there was a reason that what is S block elements? Now the element whose last electron, goes into s orbital is called s block elements. Now you have understand what is s block elements. Why I have taught you these all the things from the basic, just to make you understand what is s block elements. So as you have understand also about the s block elements, that the elements whose last electrons enters, accommodate, or you can say it goes into the s orbital is called s block elements. Now if you have seen a periodic table, then you may have seen the periodic table structure is like this. If you have seen the periodic table, then you can say, yes sir, it is like this only, right? So you can see that this 2 block, group number 1 and group number 2, and from here 3 to 12, from here 13 to 18, right? So as you can see here, this is S block elements. This is S block elements. This is, if anybody will ask you which block elements, this is S block elements. This is D block elements. This is P block elements. And this is F block elements. If you have seen periodic table, then you can recognize that sir is telling true or not, right? So this is S block elements, this is P block, this is D block, and this is F block elements. Now, in the general language, if I talk about the S block elements, means there are, if you want to represent S block elements are presented in group number 1 and group number 2. Are presented in group number 1 and 2 respectively, right? So as you have seen that S block elements are present in group number 1 and 2 respectively. Now, what are the elements in S block elements? Means group number 1 elements and group number 2 elements. The group number 1 elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And group number 2 elements are beryllium, magnesium, calcium, strontium, barium, and radium. So you have seen these two groups are known as S block elements. Group number 1 and group number 2 are known as S block elements. Right? Now you can ask me, sir, I have heard something else, the name of group number 1 and group number 2. Group number 1 means this, group number 1. Its also name is alkali earth metal. What is the group number 1 name? Alkali earth metals. Alkali earth metals. And group number 2 name is alkaline earth metals. Alkaline earth metals. Now you can ask me, sir, why their name is earth metals? Because these elements are found in earth crust, so that's why their name is represented as alkali earth metals and alkaline earth metals. Now you can ask me, sir, what is the general electronic configuration? So general electronic configuration of group number 1 is NS1 and group number 2 is NS2. The general electronic configuration. If you want the atomic number of hydrogen 1, the atomic number of lithium 3, the atomic number of sodium 11, the atomic number of potassium 19, the atomic number of rubidium 37, the atomic number of cesium 55, and the atomic number of francium 87. Similarly, the atomic number of beryllium 4, magnesium 12, calcium 20, strontium 38, barium 56, and radium 86. As you have seen, these are the atomic number of these S block elements. So if you want to take a screenshot, then just take a screenshot. After then we'll go through the NCERT concepts. Hope all of you have taken the screenshot or you have written in your notebook. Now I will move towards the NCERT textual things, that as you have seen what is S block elements, why S block name is there. There are total 4 block elements present in the periodic table, as you have seen, right? S block, P block, D block, and F block. So dear student, this was the basic concepts of S block elements. Now, first of all, just remember this is the first lecture of this S block elements. Don't forget lecture number 1. Okay? That was the basic concepts of S block elements. Now we will move through the textual things, that what are the things going to study in this S block elements. So dear students, the S block elements of the periodic table are those in which the last electrons enters into the outermost orbitals is S orbital. So S block elements. So now what is the capacity or tendency of S block elements? Capacity and tendency means, you can ask me, sir, what is this capacity and what is this tendency? Means, I just want to say you that S orbital, S orbital means spherical orbital. It is spherical. The shape is spherical, just like this. And maximum, it can accommodate maximum 2 electrons. How many electrons? 2 electrons it can accommodate. Means one spin and anti-spin, right? Clockwise and anti-clockwise. So this is that's why you can ask me, sir, is it things following all the group table? Yes. You can see there are only 2 groups in S block elements, group number 1 and group number 2, because S orbital can maximum accommodate 2 electrons. P orbital can accommodate maximum 6 electrons, and there are total 3 orbitals in P orbital. If I talk about the D block elements, then you can see there are total 10 groups in D block elements, because D orbital can maximum accommodate 10 electrons. Similarly, if I talk about the F orbital, so there are 7 D energy levels. So it can accommodate maximum 14 electrons. So you will see there are 14 groups divided into the F block elements. So dear student, now you have understand that why S block elements have 2 groups. S block elements have 2 groups because S orbital can maximum accommodate 2 electrons. So that's why it is having 2 groups. P orbital can maximum accommodate 6 electrons, so it is having 6 groups. D orbital can maximum accommodate 10 electrons, so it is having 10 groups. And F orbital is divided from the group number 3, but it can accommodate 14 electrons. So you will see either in 4F or 5F there are total 14 elements. So that was a basic concept that you should know about the S block elements. Now, as the things which we have studied about this alkali and alkaline earth metals, group number 1 and group number 2, now we are moving towards, among all these metals, sodium, potassium are the abundant, and lithium, rubidium and cesium have much lower abundance. Now you can ask me, sir, these elements, as you have said, from hydrogen till beryllium, group number 1 and group number 2 elements. So we'll discuss their properties also. Group number 1 and group number 2. This is 1 and that is 2. So group number 1 elements name, we will write their proper name, hydrogen. In the second period, lithium. In the third period, sodium. Potassium, rubidium, cesium, and seventh one is francium. Right? And group number 2 elements are beryllium, magnesium, calcium, strontium, barium, and last one is radium. Right? You can write these elements' original name in your notebook, as you have seen. Now question is about occurrence of these elements. How do they occur? Means the percentage in nature, the percentage about the isotopes. How are they occurring? Now the main things what we are going to study means in this S block elements, the main topic, what are the things we are going to study. First of all, we should know what are the relationship, anomalous relationship between this group number 1 and 2. After that, we will also discuss about group number 1, alkali metals, physical, chemical properties. What are the physical properties, as we have discussed in the hydrogen chapter also about the physical properties, means what are the physical properties of this group number 1 elements. Then we will discuss about the ionization enthalpy, the physical property. We will discuss about the ionization enthalpy. We will also discuss about the hydration enthalpy. Then we will go through the electronic configuration, physical properties, chemical properties, and finally we will move towards uses of this group number 1 and group number 2. All these things we are going to. After that, the general characteristics of this alkaline and alkali earth metal. So let's start with the topic called the relationship between the group number 1 and 2. Lithium and beryllium. You can see here lithium and beryllium, because in the group number 1 hydrogen, already one chapter in 11th standard which we have studied in chapter number 9. This is our chapter number 10. So the first two elements of this S block we can consider as a lithium and beryllium, which exhibit same properties which are different from those of other members of the respective group in this anomalous property. Anomalous properties means, they resemble the second element of the following groups. This lithium shows the similar to magnesium, means anomalous property means you can say lithium, magnesium, sodium, calcium, potassium, strontium, rubidium. That's called anomalous, but it is only represented in group number 1 and 2. That especially I talk about the resembling of the property in the second element of the following group. Lithium shows similar properties to magnesium, beryllium so to aluminium. Similarly, you can say it is only in group number 2 and period number 2 and period number 3. So this property, diagonal similarities, in the commonly referred to as a diagonal relationship in the periodic table. The diagonal relationship is due to the similar in ionic size, or it is due to the similar in ionic sizes. It charges the radius and ratio in the elements, monovalent sodium and potassium ions, and the divalent magnesium and calcium ions, which are found in the large proportion in biological fluids. These ions perform important biological functions such as maintenance of ion balance and nerve impulse conductance. So dear students, so first of all, this anomalous property, it is only present in group number 2, period number 2 and period number 3. Now you should remember the period number 2 elements and period number 3 elements, 2 and 3. So period number 2 elements are lithium, beryllium, boron. In period number 2, boron, carbon, nitrogen, oxygen, fluorine and neon. And in group number 3, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So this property means lithium shows similar properties as magnesium, beryllium shows as aluminium. So this is called anomalous property, means it is also known as a diagonal relationship between these elements. So now question is, why this diagonal relationship in these elements? You can ask me, sir. So first of all, dear student, we will discuss one to one about first group and second group elements, that what are the uses, how they are important in which field, especially as we have discussed about the group number 1 and group number 2 are mainly used in the biological fluids, because these are alkali earth metals in the form of minerals. Sodium chloride, we are eating salt, right? Potassium, each and every element is present in our body. So in the biological fluid, what are the percentage of these elements, each and everything we are going to discuss. So dear student, our first main, we will study about the group number 1, that is hydrogen to lithium. So now we will consider this S block elements from lithium, not from hydrogen, because hydrogen already we have studied the whole chapter about the hydrogen, right? So now dear students, so let's start with the lithium. Now first of all, the alkali metals show regular trends in the physical and chemical properties. Now first we will start with the electronic configuration. Now can you tell me what is the electronic configuration? General electronic configuration. General electronic configuration. What is the general electronic configuration? That is NS1. Means hydrogen is having 1s1. What's about the lithium? 1s2, 2s1. What's about the sodium? 1s2, 2s2, 2p6 and 3s1. Right? What about the potassium? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. What about the rubidium? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6 and 5p1. 5s1, not 5p1, sorry. 5s1. 5s1. Now what's about the cesium? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Right? After 5s2, you know what we are going to have? 4d10, 5p6 and 6s1. Now before, one more thing you should remember, dear student. Here after the 4d means you can say 6s1, right. Now let's talk about francium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, after 6s, 4f14, 5d10, 6p6 and 7s1. So these are the general electronic configuration of this group number 1 elements. You can say general electronic configuration means last electron is entering into the s orbital. All the alkali metals have one valence electron, that is ns1, in the outside, the noble gas over the loosely held s electron in the outermost valence shell of these elements, makes them the electron most electropositive metal. The readily loose electron give monovalent M plus ion, hence they are never found in the free state in nature. So dear student, first of all, you can see the last electron is in one, means last electron is having one electron in the outermost orbital. So as you can see this electronic configuration, they are having the property to lose last electron, because before that they are gaining the nearest inner gas configuration, so they can lose their one electron easily, and they are found in the electropositive metal form. Means lithium will be found as a Li plus, sodium Na plus, potassium K plus. Why? Because they are having, if they lose one electron, they become electropositive elements and they get the stability also. So I hope that all of you have written. One more thing you can write, that instead of this electronic configuration, you can use 1s1 for hydrogen and helium 2s1. Instead of 2p6, you can use neon 3s1. Instead of 3p6, you can use argon 4s1. Instead of 4p6, krypton 5s1. Instead of 5p6, xenon 6s1. Instead of 6p6, you can use radon and 7s1. So you can write like this also. as this is the long form as I have shown you that how to write the right electronic configuration, but we should not go like this long. We should write this electronic configuration: helium 2s1, neon 3s1, argon 4s1, krypton 5s1, xenon 6s1, and radon 7s1. Hope all of you have understand about the electronic configuration, right? Now the next topic which is present in your NCERT is atomic and ionic radii. You know very well the second property, that is atomic and ionic radii. What is this atomic size? You know, radius, that's called radii. So as you know, the first group element will have, this was the radius, second group this, third group this. So as you can see, as we move from top to bottom in a group, the atomic size increases. The alkali metals have the largest size in the particular period of the periodic table. With the increase in atomic number, the atom becomes larger. The monovalent ions are the smaller than the parent atom. The atomic and ionic radii of alkali metals increases on moving down towards the group. That is, they increase their size in going down towards the group from lithium to cesium. So dear student, as I have said you, from group number 2 to means period number 2, group number 1. This is period and this is group number 1. From the second period till the 7th period, means from lithium to cesium. Francium is radioactive. So as you know, as we move down towards from the group, the atomic radius will increase. And if I talk about metal to metal plus, whose atomic size will be greater? Can you tell me? Sodium or sodium plus? Sodium size will be greater or sodium plus size? Can you tell me? Just compare and tell me whose size will be greater. The monovalent ions are smaller than the parent, means sodium size will be greater, because as sodium loses one electron, its atomic size decreases. So you can say, as we move left to right in the period, the atomic size decreases, and all the elements can give ions properties. So that's why the ionic radius also decreases as we move from left to right in a periodic table. Now the third property, if I say about, that is ionization enthalpy. What do you mean by ionization enthalpy? All these things we have already discussed in chapter number 3. I hope all of you have remembered also. The third property is ionization enthalpy. Can you tell anyone what is ionization enthalpy? Ionization enthalpy, IE1, IE2, or it is also known as ionization potential. The minimum energy required to remove an electron from an isolated gaseous atom. The minimum energy required to remove an electron from an isolated gaseous atom is called ionization enthalpy. Now the question is, from lithium to cesium, if I talk about, okay, from lithium to cesium, if I remove one electron, then it will become lithium plus. If I remove one electron from cesium, it will become cesium plus. So you know very well how these things are being done, as we have discussed in the thermodynamics chapter also. First of all, this element will convert into the gaseous state, and after that, from gaseous state we give to remove one electron we require some energy. That energy that is called ionization enthalpy. So if we remove one electron, that will be called IE1. If we remove two electrons, that will be called IE2. If we remove three electrons, IE3. So you know very well, these are monovalent atoms, means they are having last one electrons in their outermost orbit. So it's very easy to remove, because as they can lose one electron from their outermost orbit, they will get nearest inert gas configuration. So if we talk about and if we compare about the ionization potential 1 and ionization enthalpy 1 and 2, so here 1 is less than 2, means because the second electron is having the inert gas configuration, and to remove the second electron from this alkali earth metal, we require more and more energy in comparison to first electron. So dear students, to remove one electron from an isolated gaseous atom from the alkali metals is called the ionization enthalpy of alkali metals. From lithium to cesium, if I talk about, the ionization enthalpies of all the alkali metals are considerably low and decrease down the group from lithium to cesium. This is because the effect of increase in size outweighs the increase in nuclear charge, and the outermost electrons very well screened from the nuclear charge. So dear student, as we have already learned that from top to bottom in a group means from lithium to cesium, we require, means to remove lithium electrons will require more, but if we compare cesium and lithium, we require less electrons. Why? Because the electrons which is attached with the nucleus, because it is having only 2 orbits, but this is having 6 orbits. So that electrons will be more far, nuclear effect, screening charge. So you know very well that all the things. So to remove one electron from an isolated gaseous atom of these alkali metals, we require less energy because these are monovalent or electropositive elements. So this is our ionization enthalpy. Now last one, before moving towards the physical properties, I would like to see you about the hydration enthalpy. Do you know hydration? The hydration enthalpy of all the alkali metal ions decrease with increase in ionization. Decrease with increase in ionization means, if we talk about the hydration enthalpy, if the elements change into the ions form, then each and every element's ionization will increase. Just let me write hydration enthalpy. Now third property is hydration enthalpy. That was ionization. Now we are talking about hydration enthalpy. Now you can ask me, sir, what is this hydration enthalpy? As we move from top to down, means lithium plus, sodium plus, potassium plus, rubidium plus, and cesium plus. As this electropositive elements, the hydration enthalpy of all these alkali metals, as they convert into the ions, now they will decrease with the increase in ionic sizes. Decrease with the increase in ionic sizes means as the ionic size is greater. So you can say here the cesium hydration enthalpy is less than rubidium. Rubidium hydration enthalpy is less than potassium. If they are in the ionic form, means electropositive. Similarly, sodium and lithium. So as we have seen here that lithium has the maximum degree of hydration. For this reason, lithium salts are mostly hydrated. You know lithium salt, I can say you lithium chloride. It is hydrated form in the LiCl into 2H2O. Just like copper sulfate we studied, CuSO4 into 5H2O. Similarly, lithium chloride, this is the salt of lithium which is existing in the form of LiCl into 2H2O. So as the ionic size increases, the hydration enthalpy decreases. So here you have seen lithium chloride has the maximum hydration enthalpy. Okay. Now the next we are going to discuss, that is physical properties. You know very well what is physical properties. Physical properties in the sense of atomic number, mass number, electronic configuration, ionization enthalpy, hydration enthalpy, metallic radius, ionic radius, melting point, boiling point, after then density, and then you can say standard potentials or occurrence in atmosphere or lithosphere, you can say. So these are the few physical properties. So for that we have to draw one table for the physical properties. First of all, as this table is already represented in your NCERT textbook in page number, or you can say that table number 10.1, right? So first of all, we have to write what are the physical properties. These were also the physical properties only we were discussing. So no need to worry, dear students. One to one we will study all the physical properties. Okay. All the alkali metals are silvery white, soft and light metals. Because of the large size, these elements have low density, which increase down the group from lithium to cesium. However, potassium is lighter than sodium also. The melting and boiling points of all the alkali metals are low, indicating weak metallic bonding due to the presence of only a single valence electron in the outermost orbital. The alkali metals and their salts impart the characteristics of color to an oxidation flame. This is because the heat from the flame excites the outermost orbital electron to a higher energy level. When the excited electron comes back towards the ground state, there is an emission of radiation in the visible region of the spectrum, as you can see that lithium converts into red color, sodium converts into yellow color, potassium in the violet, rubidium in the red violet and cesium in the blue. Alkali metals can therefore be detected by the respective flame test also, and can be determined by the flame photometry or atomic absorption spectroscopy. These electrons, when irradiated with the light energy absorbed may be sufficient to make an atom lose electrons. So dear student, first of all, in the physical properties, flame test. First physical property was flame test. Flame test, why flame test? Because they are having the last electrons, means valence electron is 1. So from lithium to cesium, if you want to confirm which ion is present in that salt, so by the flame photography also you can confirm. Especially these all are things of practical chemistry, practical S block element. You can say that flame test or element test, you can say that. Means it will be confirmed by the colors. If I talk about the lithium, that is crimson red. If I talk about the sodium, yellow, potassium, violet, rubidium, red violet, cesium, blue. So dear student, first of all I would like to say you that in your notebook you must draw this group number 10.1 table, and after that we will discuss about the chemical properties and then uses, right? So first of all you should draw this group number 10.1 table, means table diagram you should draw in your notebook, and then we will discuss. So each and everyone just pause for a second and draw that physical properties, chemical properties, means all those physical properties, chemical properties and uses. We will discuss in the next video, but you should draw in your notebook, you should write about the atomic size, ionic size, electronic configuration, atomic number, atomic mass, density, melting point, boiling point, and the last one, which is more important, that is standard potential and occurrence in lithosphere. These all the things must be drawn in your notebook in a table, as while remembering that what is the melting point of lithium, what is the melting point of sodium, what is the melting point of potassium, rubidium, cesium. That things can come in your mind. Ionization enthalpies from lithium to cesium, boiling point from lithium to cesium. These all things, if it will be represented in a table, that frame will come in your mind. So in the next video we will specially discuss about the physical properties, chemical properties and the uses of group number 1. In this video we have just given an introduction of S block elements and some of the physical properties like general electronic configuration, what will be the electronic configuration, ionization enthalpy, hydration enthalpies. So dear student, you should draw that table in your notebook. In the next video we will meet and we will discuss more about the S block elements. That's all for today. Thank you very much. Hope your day should be a good. That's all. Thank you very much. Don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.